So welcome back. This is lesson 2 of week 7, and in this lesson we're going to look at a couple of new examples of how we can turn circuits into expressions and create truth tables. So in this lesson we'll turn a circuit into a logical expression twice. We'll do 2 worked examples and we'll look at a truth table with up to 4 inputs. So here's an example circuit. You can see I borrowed it from Electronics Hub, and I'm going to work out the equivalent logical expression to this circuit. So as always, see if you can keep ahead of me. That would be a really good way to test your understanding and then check immediately with what I do. So what do we do first? First, I like to label all the outputs, in this instance D and D, so that every step of the circuit is labelled. And then I'm adding these lines to put my circuit into layers because I'm going to work backwards. You don't have to do that. In a way, that's just a teacher thing. I'm doing it to make it clearer to you how I'm working backwards. If you can do that in your mind, that's fine. So let's do that now. Starting from the final layer, we're going to replace each letter with the expression that is equivalent to that letter. So our final letter is Y. So Y is the output of an OR gate, and the inputs to the OR gate are D and E. So Y is D or E. I expect you know what I'm going to do next. I'm going to replace D and then E with their equivalent expression. So D is A XOR B, and E is B XOR C. I can see that immediately. They're XOR gates and those are the inputs to the gates. So let's go back to our expression and put that in. Our expression now consists entirely of A, B and C, which are our inputs. So I'm finished. I've finished that task. And I can also write it using Boolean algebra, and that's the answer to that exercise. Let's make a truth table from the circuit as well, because that's good practice. I'm going to show that in a minute. There it is. I hope you got that. If you didn't stay ahead of me, well, there's going to be more practice. So just as soon as you can, start trying to work independently. So here's another exercise. Copy this circuit into your book or a piece of scrap paper and start working through this. See if you can do everything. I'm going to turn this into an expression and then I'm going to create a truth table. So see if you can do it. Label the gates, mark the layers. What are the operations at each stage? Build up from the right. Z is the output of an OR gate, isn't it? So Z is E or D. Don't be put off by the splits in the wires. You just follow the wire back to where it came from. So Z is E or D. Now I'm going to substitute E, D and C for their equivalent. E is C and D. D is A or B. So everywhere I see D, I'm going to put A or B. And incidentally, I'm going to put it in brackets because OR is low down on the level of precedence. And if I don't put it in brackets, it won't work properly. So D occurs twice, and everywhere I see D, I've put A or B in brackets. Okay, I've got one final thing I've got to swap. C C is not A, so let's quickly do that. And I've got there because my final expression is it's a much bigger expression, but it's made entirely out of A's and B's. So that's the circuit and that's the expression. So see if you can write a truth table to match that. I'm going to put that up on the screen in a moment or two. So if you haven't done it already, pause the video and draw that truth table. There it is. It's a relatively simple truth table. It's only got 4 rows because everything's made out of A and B. And that's the final output. So I hope you got that right. And here's our third and final worked example of this lesson. This one's harder because it's got 4 inputs. So I don't know if you're already thinking what that truth table might look like. But have a go at this now. As always, see if you can do it now without me even starting to tell you how to do it. So this would be a good point to pause the video. If we were in class, you know, I'd be getting you to do this in class. So labeling and showing the layers. Work from the right backwards. I'm not going to do this today, so you've seen a lot of examples. Have a go at this now. So that's the Boolean expression that matches the circuit. I hope you got that. There it is written using the Boolean symbols. You may have used more brackets than that, which is fine. I've just shown it with the minimum brackets that you can get away with. I'm about to bring up the truth table. Notice that it's a 4-value truth table. That means that there are 16 different possible combinations. So pause the video and write this truth table now. There are the possible combinations of inputs when you've got 4 input values. I rarely see this many in the exam, not least because it simply just takes quite a while to write them all down. So they usually stick to 2 or 3 input values in the exam. But if you can tackle this, you can more or less tackle everything. And here are at the top of the columns, you can see that I've written in the values for E, F, G, H and the final output. So if you were stuck before, this is how to set out the table, complete the columns using the methods that we've already learned. I'm about to show you the answer, so see if you can get this done. And there's the answer. When I'm checking somebody's work, a good way to make sure they've got the right general idea is to look at the final column. So if you're not sure if you've got it right, compare your final column with this, because the chances are quite slim that you would get all those noughts and ones right unless you'd got the rest of the column right. So just check that your final column looks like my final column. So if you managed to do those, well done. Particularly that final one was a really difficult example, and there are 2 more lessons left in this for this week, which will conclude our work on logical expressions and gates. We're going to look at some real life examples. So if you're given an example in words and you have to turn that into logic, and the final lesson has got lots more practice, because I think that's the way to get good at doing this. All right, so I'll see you in lesson 7.3. Bye for now.